Assalamualaikum dan salam sejahtera. Apa khabar semua? Sihat? Tajuk pembelajaran kita pada hari ini adalah pengenalan komponen turbocharger dan supercharger. Objektif pembelajaran kita hari ini adalah 1. Senaraikan komponen turbocharger dan supercharger. 2. Huraikan fungsi turbocharger dan supercharger. 3. Terangkan perbezaan turbocharger dan supercharger. Objektif yang pertama sekali adalah senaraikan komponen turbocharger dan supercharger. Berikut adalah komponen yang ada pada sebuah turbocharger dan supercharger. 1. Compressor wheel. 2. Turbine wheel. Kedua-dua komponen ini dipasang pada shaft yang sama. Compressor wheel memampatkan udara, manakala turbine wheel mengeluarkan gas exhaust. 3. Wastegate. Wastegate berfungsi mengelakkan tekanan udara yang berlebihan daripada memasuki silinder dan membuang tekanan udara yang berlebihan. 4. Drive belt dan pelinciran. Drive belt dan minyak pelincir adalah komponen bagi supercharger. Drive belt berfungsi untuk menggerakkan supercharger dengan mengikuti putaran enjin. 5. Blow off. Blow off pula berfungsi membuang tekanan udara berlebihan dan menghasilkan bunyi apabila throttle dilepaskan secara mengejut. 6. Actuator valve. Actuator valve membuka bypass valve menggunakan gas exhaust dan membuang gas exhaust yang tidak diperlukan daripada masuk ke dalam turbin. 7. Oil pressure hose and pipes. Seterusnya adalah oil pressure hose and pipes yang berfungsi sebagai laluan minyak pelincir pada turbo bagi tujuan melicinkan bearing yang berada di dalam center bearing housing. 8. Intercooler. Intercooler menyejukkan tekanan udara yang telah dimampatkan sebelum memasuki silinder bagi tujuan pembakaran di dalam enjin lebih efektif. Seterusnya adalah fungsi turbocharger dan supercharger. Turbocharger dan supercharger merupakan sebuah sistem kenderaan yang menggunakan tekanan udara. Pada masa kini, kebanyakan kenderaan yang menggunakan sistem ini kerana membantu meningkatkan prestasi enjin pada kenderaan. Turbocharger dan supercharger merupakan satu sistem yang mana menggunakan tenaga kinetik dan kuasa haba yang tidak diguna daripada exhaust manifold bagi meningkatkan isi padu udara yang masuk ke dalam enjin melebihi isi padu biasa, bagi meningkatkan output enjin dan mengurangkan penggunaan bahan api serta meningkatkan kuasa enjin. Mari kita lihat video bagaimana turbocharger dan supercharger bekerja.
Creator of animagraphs, and this is how superchargers versus turbos work. The basic function of both superchargers and turbos is to deliver more air to an engine's internal combustion process. The main distinction between the two is this: superchargers are mechanically powered, often by connection to the engine crankshaft, while turbos are powered by engine exhaust gas. Let's look at how each unit works, starting with the supercharger. The supercharger type shown here sits on top of the air intake manifold. A serpentine belt transfers crankshaft power to the supercharger pulley. Pulley diameter and construction is an easily accessible way to quickly alter supercharger performance characteristics. A gear drive system delivers incoming power to opposing rotors. Outside air enters through the air filter and intake pipe. Interlocking rotors force air through the supercharger. The long fins or ridges that span the length of the rotor shaft are called lobes. Air exits the supercharger through a specially shaped discharge port at the bottom of the housing. Here are a few common supercharger types. Roots. The Roots type supercharger saw its first automobile application in 1900. The term blower or blown engine originates from the Root supercharger's basic function as an air blower, as opposed to other designs that compress air. Twin screw. Twin screw type superchargers feature complex rotors with intricately designed lobes that compress air as it moves through the unit. This increased complexity results in better performance, but also higher manufacturing cost. Centrifugal. Centrifugal superchargers have much in common with the turbo design concept, though they are still mechanically driven. They produce an exponential power curve and are often tuned to make full boost at engine redline. Now, let's look at how turbochargers work. The turbo connects to the engine exhaust system. In turbo setups, the exhaust manifold may be specially designed for turbo placement and to handle increased heat and pressure. The turbo has two separate compartments called the turbine section and the compressor section. Exhaust flows through the turbine section as exhaust heat or exhaust wheel. A sealed shaft connects the exhaust wheel to the compressor wheel. The compressor wheel pulls air in through the air filter and intake pipe. Its specially shaped fins force air through an increasingly smaller chamber, building compression. Air gets hot during intake and compression, so most turbo setups have an intercooler between the turbo and engine intake to get air back down to ambient temperatures. Cooler air has greater density, serving the goal of forcing more air into the engine. The intercooler works something like a radiator. Hot air passes through internal tubes as outside air rushes by for cooling. Here are some common turbo designs. The single turbo, shown here, where all exhaust flows through a single turbocharger. Twin turbo. A setup with two turbochargers, for example on a 6-cylinder engine with one turbo for each cylinder bank. Twin scroll turbo. Exhaust exits the cylinder in a pulse, with a high pressure section followed by low pressure. Twin scroll turbos separate cylinders into pairs so that exhaust pulse waves do not interfere with each other, and a continuous stream of maximum pressure exhaust reaches the turbine. Now, let's compare superchargers and turbos in very general terms. Again, superchargers are powered by mechanical energy, for example by connection to an engine's crankshaft, while turbos are powered by otherwise wasted heat energy from engine exhaust. Boost characteristics. Roots and twin-screw superchargers have positive displacement, meaning that they move the same amount of air for each engine revolution, regardless of RPM. This also means that they can make boost immediately, even at very low RPMs, and have a fairly linear power curve. Turbo setups produce an exponential power curve. Since they are powered by exhaust, turbos take time to build turbine speed and pressure before producing usable boost. This delay is called turbo lag. Efficiency. Superchargers take power to make power, and an average setup can require 40 to 60 horsepower to function. This doesn't mean that overall engine efficiency is always sacrificed, as some setups can increase fuel economy when not driven aggressively. Though turbos do increase back pressure on the engine, they derive power primarily from otherwise wasted exhaust heat as opposed to exhaust flow pressure. turbos might require more peripheral parts like oil and vacuum lines, an intercooler, custom exhaust manifolds and exhaust piping, and so on. Turbos can require more skill to properly configure. However, a well-tuned turbo system may be able to produce boost more efficiently and in greater quantity than a supercharger.
Begitulah jalan kerja sebuah turbocharger dan supercharger. Seterusnya adalah perbezaan turbocharger dan supercharger. Baiklah, tersebut adalah perbezaan turbocharger dan supercharger dari pelbagai aspek. 1. Sumber kuasa turbocharger menggunakan tenaga daripada gas exhaust. Supercharger digerakkan oleh tali sawat. 2. Respon turbocharger mengalami turbo lag. Supercharger respon yang serta-merta dan tidak mengalami turbo lag. 3. Kecekapan bahan api. Turbocharger lebih cekap dan tidak menggunakan kuasa enjin secara terus. Supercharger kurang cekap, menggunakan sebahagian kuasa enjin. 4. Prestasi pada RPM rendah. Turbocharger kurang prestasi pada RPM rendah. Supercharger lebih berkuasa pada RPM rendah. 5. Pemasangan turbocharger lebih rumit, perlukan sistem exhaust dan penyejukan tambahan. Supercharger lebih mudah dipasang. 6. Suhu operasi. Turbocharger beroperasi pada suhu tinggi dan memerlukan intercooler. Supercharger kurang menghasilkan haba berbanding turbo. Sampai sini saja pembelajaran kita hari ini. Terima kasih kerana telah menonton video pembelajaran ini. Sekian terima kasih.